Hey everybody, it's Mrs. Woolley. Thank you so much for joining me. This week we're going to look at solving quadratic equations using three different methods. We'll start with square roots, then we'll apply factoring and zero product property, and lastly we'll use quadratic formula. Quadratic formula does require that you memorize a formula, and it will always work for any quadratic function that you're trying to solve for. I want to remind you it's really important, very, very important, that before you go into the weekly assignment, you watch all the videos that are included in this Google Slides presentation. So the first one is an overview on solving the quadratic equations deck, and it's navigating through the deck, giving you your different options and explaining the assignments in it. So if you bypass this video, you will probably regret it because you will run into some problems somewhere along the assignment, along the board. So please take time to watch that video. It's a little over 13 minutes long. It's a little bit longer than usual, but it's well worth it. So our first factoring technique that we're going to look at is solving equations by taking the square root. So the process is to isolate the square root symbol. And you will have three different cases. If it's equal to 0, well, then that's your solution, 0, 0. If it is greater than 0, well, you're going to have two real number solutions. And if it is less than 0, then you have no real number solutions, and you'll be looking at two imaginary number solutions. You will learn about that later on probably in Algebra 2. So the first step is to isolate the absolute value symbol. And in this first example, we have n squared equals 121. So you can see that on the left-hand side, the quadratic term n squared is isolated. So now we're going to apply the quadratic formula, which means we're going to take the square root of both sides. And you know that the square root of n squared cancels. They undo each other. Well, on the other side, when you take the square root, you are going to have a principal and a negative square root. So this goes back to your number theory. When you are multiplying two numbers and signs are the same, your product will be positive. So you can multiply, in this case, 11 times 11 equals 121. As does negative 11 times negative 11. So in this case, you have two solutions, and n could equal positive 11 or negative 11. Now, I could write that as using set notation, negative 11, comma 11. All right, so let's try another example. And in this example, 3x squared equals 300. We need to isolate the x squared term. So in order to do that, we're going to undo our multiplication by dividing both sides by 3. So when we do that, we have x squared equals 100. Now I'm going to show you a shortcut way to write this. Instead of writing the square root of both sides to show the principal and negative square root, that extra step that I had done, I'm going to eliminate that and just write x equals plus or minus the square root of 100. And you know that the square root of 100 is 10. And so your solution is plus or minus 10. And so you could always substitute that back into the original equation. 10 times 10 is 100, times 3 is 300, and negative 10 times negative 10 also is 100, times 3 is 300. And so the last example that we're going to try, well, second to last example that we're going to try, is a little bit more work to isolate the absolute value symbol. And so in this case, we have to undo our multiplication by dividing both sides by 5. And then you'll notice that there's something attached in the square root, in the squared. I want to remind you that you're going to take the square root. You just like absolute value, when you have a squared, you never go in. You always take the square root of both sides first, and then you do the operations inside the parentheses. All right, so let's start this equation by dividing both sides by 5. And when we do that, we have x minus 1 quantity squared equals 49. Now, when I take the square root of both sides, I need to remember there is a principal and a negative square root of 49. So it's plus or minus the square root of 49. Oops. So what I'm going to do is actually erase this, because it should be x minus 1 equals plus or minus the square root of 49. And I know that the square root of 49 is 7. Now, there are two solutions to this. So at this point, I'm going to bust this up and write both solutions. Okay, so x minus 1 equals plus or minus 7. So I'm going to bust this up, and I'm going to have x minus 1 equals 7. And I'm going to have x minus 1 equals negative 7. So I'm writing two different equations, and I'm going to solve each of these equations separately to give me my two solutions. And I'll do that by adding 1 to both sides of the equation. Okay, to solve the first equation, I'm going to add 1 to both sides, and I'll have x equals 8. To solve the second equation, again, I'll add 1 to both sides. And in this case, I will have x equals negative 6. And so if I was to substitute those two values in, 8 minus 1 is 7, and I know 7 times 7 is 49, times 5 is 245. If I would substitute negative 6 in, negative 6 minus 1 is negative 7. Negative 7 times negative 7 also equals 49. And 49 times 5 is 245, so my solutions check. And to write my solutions in set builder notation, it would be negative 6, 8. All right, so that is solving by taking using the square root method. And so the next strategy that we're going to look at is solving by factoring and using something called zero product property.